Hey, what's going on, guys? Let's do this problem right here. The question is asking the 60 watts fan of a central heating system is to circulate air through the ducts. The analysis of the flow shows that the fan needs to raise the pressure of air by 50 pascal to maintain the flow. The fan is located in the horizontal flow section whose diameter is 30 cm at both the inlet and the outlet. Determine the highest possible average flow velocity in the duct. So let's see how we can find this one. So first of all, to find the energy, like here we are going to use the energy equation to find these things. But first of all, we have to know what are the energy existing right here, right? So to find that one, we can bring this equation that delta E system is equal to Q in, Q out. So this is heat energy, Q in minus Q out, and plus W in minus W out. So this is added work, and the work eliminated, like work done by the system, something like that. Yeah, and then plus E mass in, E mass out. So this is work due to the mass, E mass in, E mass out. So these are the energy that's going to be in the system. So here we can cancel all the energy that does not exist. So let's do that one first. So here we are not having any heat energy, right? So we can cancel both. We are not having any, like there's no heat added or eliminated from the system. So we can cancel both of these. And we are adding work by this fan right here. So work in is there, but work out, there's no work out right here. So we can cancel that one too. And we are left with this E mass in. We are going to have E mass in due to the duct flow. So E mass in and E mass out. So those are the three things we have. But we can use another equation to substitute these values. That is E in minus, this is same as this one. E in minus E out is equal to 0, right? So this is the one we are going to use. So here E in we have W in plus E mass in, E out we have, so we can say E in is equal to E out. E in is equal to E out. So E mass in, W in, E mass in we have, and also E mass out we have. So we have E mass out and all these things. W in, we can keep it in the same way. E mass in can be written as M dot, so this is per unit time, or you can say per second, per unit time times P times V1, right? Equals to M dot P times V2. So here this is volume, this is pressure, and this is mass, per unit mass, right? So let's rearrange this one and see what we get. So here we are going to have, so also this one is per unit mass, okay, that's the one. And then we can bring this P1, this MP, everything together. So W in is going to be equal to M dot PV2 minus M dot PV1, right? PV1, and volume is going to remain the same. So we can take the volume out. So M dot V is going to be P2 minus P1. So this is going to be delta P, right? So this is going to be delta P, and if we multiply this one by this one, that's going to give us what the volume flow rate, right? So volume flow rate times delta P is going to be working. So let's see how we can use this one. So if we have the question is asking to find the velocity, right? if we can find the volume, and if we divide that one by area, that's going to give us the velocity. So let's see how we can. And also we have work in that's provided, delta P is also provided, so we can find the volume flow rate. So volume flow rate is equal to work in over delta P, and we know that work in is equal to 60 watts, right? So this is per unit time. So all of them are going to be unit time, so this is joules per second, right? Unit. So that's going to be 60 watts divided by delta P, that is 50 Pascal, and that's going to give us the volume flow rate. And if you calculate this one, you will get, so this is maximum volume flow rate, maximum, and you will get 1.2 meter cube per second. Now we have the volume flow rate, and if we divide this one by the area, that's going to give us the velocity. So let's calculate the velocity. So velocity max is equal to volume flow rate max divided by the area. So here the area is going to be a circle, since it's a cylinder, right? So the cross sectional area is going to be circle, and for a circle area is going to be pi r square, right? And they have given the diameter here, so we can find that. So V max is going to be 1.2 meter cube per second divided by, since they have given the diameter, we can use 5d square by 4, right? So 5d square by 4, and that's going to give us the velocity. So let's bring the 4 to the upper side. 4 times 1.2 divided by 5d square. So here they have given d in centimeters. Let's convert this one into meter, and that's going to give us 0.3 meter, right? So we have 5 times 0.3 square, and if you calculate this value, you will get 17 meter per second, and that's going to be the maximum velocity, and that's the question is asking, right? And that's how we do these kind of problems. I hope you guys find this video helpful. Thanks for watching.